L is proportional to G, right? Or G proportional to L. G proportional to L. Take log on both sides, log G equal to log L. So delta G by G equal to delta L by L. So delta G by G equal to delta L means alpha delta T. Alpha delta T. So delta G by G into 100 equal to alpha delta T into 100, percentage calculated. Or G2 by G1 is equal to alpha into delta T. Right. Next one. C. So T is equal to 2 pi under root of L by G. Right. Temperature increases. So length of the rod increases. Time period also change. 2 pi under root of L dash by G. But L dash is equal to L into 1 plus alpha delta T. Right. T dash is equal to 2 pi under root of L into 1 plus alpha delta T by G. So T dash equal to 2 pi under root of L by G into 1 plus alpha delta T whole power half. Whole power half. So this is the T dash is equal to this is the T. T into 1 plus alpha delta T whole power half. According to binomial theorem, 1 plus x whole power n equal to 1 plus nx. So T dash is equal to T into 1 plus 1 by 2 alpha delta T. Alpha delta T. Right, T dash by T. So T dash by T minus 1 is equal to alpha 1 by 2 alpha delta T. 1 by 2 alpha delta T. So 2 pi under root of L by G, 1 plus alpha delta T whole power of root means half. Okay. The next step is a T. So next one. So T dash minus T by T is equal to 1 by 2 alpha delta T. So delta T by T is equal to 1 by 2 alpha delta T. Percentage delta T by T into 100, loss or gain of time. Loss or gain of time. So delta T by T into 100 equal to 1 by 2 alpha delta T into 100. Second one, loss or gain of time in seconds. So delta T by T is equal to 1 by 2 alpha delta T per minute. So delta T by T is equal to 1 by 2 alpha delta T. This is called per second into 60. This is the per minute. This is the per second.
So the first one is percentage.
A, B, C, D, per second per minute. Delta T by T is equal to half alpha delta T into 60 into 60 hour per hour 60 into 60. Next one, D. Delta T by T is equal to 1 by 2 alpha delta T into 86,400. 86,400 per day. 86,400 per day. Per year means multiply 365. So per day means 24 hours into 60 into 60. Per minute, per second, per minute, per hour, per day. Into 24 hours on actually. 3,600 into 24 hours. Okay. 86,400 per day. Per year, 365. Okay. This is the important final formula. Percentage formula important.
Sir,
Huh.
sir, can you tell what you told till now?
Huh?
Because I joined late, sir.
Huh.
Sir, can you tell just what you taught till now?
Which one?
Sir, what you wrote on board about
T is
what?
equal to, oh, no,
Variation in time period of pendulum motion.
time period formula already last yesterday concept.
Okay, sir.
Right. Next one is A, B, C, D, E. So next one is another one.
10th one, sir.
No. Continue. So temperature increases. For example, A, B. Okay. D part, main part. So temperature increases. So temperature increase. Length of the length also increases. Length increase. Temperature increases. Length also increase. So length increases means time period. Time period increases. Time period also increases. This is the temperature. This is the temperature. Temperature increases. Length also increase. Time period also T increases. Okay. Time period also increases. Time increases. These are loss of time. Actually, these are loss of time. Pendulum run slowly. Slow. run slow now. So pendulum runs slow. Actually, in summer season, actually this one in summer, maximum in summer. So in summer, temperature increases, length also increase, time period also increase. So loss of time, pendulum runs slowly. Yes, slow. Okay. Clock loss the time. Clock loss of time. Okay. So next one. So same temperature decreases. Temperature decreases.
Yes, ma'am.
Length also decrease. Length decreases. Right? Length decreases. Time period also decrease. Time period also T decreases. Gain of time. So pendulum runs fast. Pendulum runs faster. In this case, frequency also decreases. In this case, frequency increases. N is the frequency. Frequency. N increases. Okay. Okay. Next.
That is in winter, no sir. So the second one is in winter, no sir.
Second one.
Second one in winter, no sir.
Okay,
Temperature.
winter season, no, sir.
Winter. This is a summer, winter. Winter season. In winter, this is a summer. Right. This is a winter season. Winter. In winter. Right. Okay. So A, B, C, D, E. Here. For example, 5 seconds. 5 seconds pendulum is fast. Fast. At a temperature T1 degrees. Next one 10 seconds slow. At a temperature T2 degrees. Let correct time temperature is T1. Okay. So first one T1 degrees temperature 5 seconds is fast. At T2 degrees temperature 10 seconds slow. So T is the correct time. T is the correct time. So let the correct time at temperature is T. Okay.
Sir, don't rub, sir. 1 minute.
So actually for formula, what is delta T by T is equal to 1 by 2 alpha delta T. So this is the relation, only this is the relation. So delta T is proportional to delta small t. Okay? Right. So what is that delta T? So for example, This is the slow. The fast. This is the correct. This is the temperature is fast T1 temperature. T1 degrees C. Also T2 degrees C. This is the T degrees C. Okay. T degrees C is medium. And just is a small, medium is length, high length. Okay, na? High length, medium length, low length. Length low, fast. Medium length, correct time. So T2 is the right slow time. This is also slow time. What is the delta T? Delta T without chart ana. Chart ever chayadabba. Any doubt? Okay na? Ask me direct. Fast, correct, right. This is the fast, correct. This is the slow. Okay, right. What is the delta T? What is the difference of delta T? For example, okay, delta T is the time, delta temperature difference. Okay, for example, 5 seconds. Okay, our delta T is difference delta capital T. Okay, for example, 5 seconds. And 5 seconds means fast. What is the time difference that is equal to? What is the delta T? T minus
T1.
T1. 5. So 10 seconds. 10 seconds slow.
T2 minus T, sir.
So which value? T2 minus T.
T2 minus
T, right. So T values, T1, T values, T1 and T2 values substitute. So T value calculated. So correct time calculated. Okay. So therefore,
okay, sir.
T1 and T2 values, T2 value substitute and simplify. Substitute. Okay, simplify. And T value substitute and simplify.
20 degrees Celsius.
Simplify. And unknown value calculate, unknown value T calculate. Unknown temperature. Unknown temperature T is calculated. Is very, very, very important. Gunshot. One example problem is there, na? Gunshot, an example problem. Okay. After that, alpha value calculate. Next one, next part is A, B, C, D, E, F. Pendulum clocks, only F parts. D, E, F. So delta T by T is equal to 1 by 2 alpha delta T. Delta small t. This is the formula. Okay, this is a, for example, 5 seconds considered. 5 seconds loss of time calculated. 5 seconds is equal to alpha into 1 by 2 into alpha into, what is the delta T? Delta T value substitute T minus T1. So T minus T1 per day calculated into 86,000 per day. Per day. For example, into 86,400 per day. So R, for example, 10 seconds substitute 1 by 2 alpha into, so this is the value, T2 minus T1. So 86,400 per day. So alpha value calculated. T2, so by substituting these two values, T value calculated. So sorry, ma'am.
T2 minus T, no, sir.
T2 minus T. T2 minus T value substitute and alpha value calculated by using this formula. Okay, this is the pendulum clock's total information. So very important information. So A, B, C important. C important. So D general, C, D, D. B also important. B good important. Loss or gain of time. Direct formulas. So refer example problems. Akash material. So direct only temperature calculator.
సార్ ప్రాబ్లమ్ లో T1 ఇంకా T2 వాల్యూస్ ఇస్తారా?
12.23 problem. 12.23 are individual 12.23 and 12.24. Okay, 12.23 and 12.24. And this is a separate problem. 5 seconds, for example, 5 seconds passed. At a temperature is 13 degrees C, 15 degrees C. 10 seconds slow. At a temperature is 30 degrees C. Find the correct temperature calculate. This is the one problem. Okay, only this part. Only this part. 5 seconds fast at temperature 15 degrees C. 10 seconds slow at the temperature is this one is 30 degrees C. So correct time of temperature calculated. So 5 by 10 is equal to T minus T1. T1 value 15. So T2 value 30. 30 minus. So simplify T value calculated. This is the one problem. So alpha value calculated. Down problem not 12.24. 12.24. 12.24. Okay. Loss or gain of time per day. 1 by 2 delta T 86,400. So 15 seconds clock. Okay. Last fast and 10 seconds slow. So first T value calculate. T value calculate. After T value calculate, loss or gain of time. This is the formula. So for example, 10 seconds substitute 10. So 10 value substitute alpha into T2 minus T into 86,400. Or 5 take 5, no problem. 5 is equal to 1 by 2 alpha T minus T1. Okay, T value is 20, given question 20. So T1 value 15. So 20 minus 15 into 86,400. Same answer. Or 10 is equal to half alpha into T2 value 30. 30 minus 20. So 86,400. So alpha value calculate. Okay. Problem. Example problem 12.24. 12.24. Example 12.24. Very important gunshot. Gunshot application. Gunshot these two.
Sir, exercise 3, 12th one.
Exercise 3.
12th one. Same application. One answer.
Pendulum clocks, number of problems actually. Pendulum clocks, so exercise to 30th problem. And 20th, 29th problem. Okay, third exercise 17.
12, sir.
12. Okay, right. Exact. A pendulum clock 5 seconds fast at a temperature 15 degrees C, 10 seconds slow at a temperature 30 degrees C. The temperature at which given correct time. So important. Gunshot.
20 degrees Celsius will get, sir.
Exercise 3. Only this problem. Only. Exercise 3. 12th problem. So the pendulum clocks 5 seconds fast. 5 seconds fast is the temperature is 15 degrees C. Same example problem. 10 seconds slow. So temperature is 30 degrees C. Correct temperature calculated. Correct time temperature. Correct time temperature. Same formula. 5 by 10 equal to T minus T1 by T2 minus T. So 5 by 10 is equal to T minus 15 by 30 minus T. 5 1 ja 5 2 ja. So 2T minus 30 is equal to 30 minus T. Right? 3T is equal to 60. 3 1 ja 3 20 ja. So that implies T equal to 20 degrees. Third exercise, 12th problem. This is also G problem. G problem. Third exercise, 13th problem. C application. C and L relation. C and L. G values are given, G1 minus G2, half alpha delta T. 13th also important, 12th to 13th. So 12th one gunshot, very, very important. Very, very important. Okay, this is called pendulum clocks. So next application. Thermal stress or thermal force. Thermal force in an object due to thermal expansion. Due to thermal expansion. Right, due to thermal expansion. Right. A rod of length is L, area of cross section is A. Is tightly fitted to two rigid walls. Wall. Okay, rigid wall, two tightly fixed. Two rigid walls, vertical walls. Okay, a rod of length is capital L, and the area of cross section is A. Is a tightly fitted with two vertical walls. Right. So next one, for example, the surrounding temperature decreases. Surrounding temperature decreases. Surrounding first condition, if surrounding temperature decreases. Surrounding temperature decreases, the rod contracts. The rod contracts. Okay. The rod contracts. The rod contracts and fall down. Okay. Surrounding first one, a rod of length is L, area of cross section A is fixed between two rigid walls. So right, both are walls, vertical walls, right. The surrounding temperature decreases. So decreases, the rod contracts. So contracts means decreases, length decreases. So rod fall down. Okay, right. So second one is if the surrounding temperature increases, the rod expands on both sides. So both sides expand. So both sides expand. This is the some force acts. So normal force. And the temperature is increases. First one, temperature is decreases. So rod contracts and fall down. So temperature increases, the rod expand. Some force acts on both sides. Expands on both sides. And some force acts on walls. This force is called normal reaction force. Normal reaction force acts on it. At the same time, according to Newton's third law, action and reaction. So rod, some force acts on the wall also some force acts on the rod. This is the same force. These two forces are equal magnitude but in opposite direction. Okay, opposite direction. So rod, so not a, okay, na, sometimes is a tightly, full tightly, okay, tightly in between the walls. Tightly, more tight, okay, na, some expands. So tightly between the two walls. Some stress also acts in the wire, in the rod. Some stress also developed. Stress and strain developed. In a rod. What is the stress? Stress means some force. Normally force acts on it. So this is called thermal force. So not due to temperature increases. So rod also expand. So some force act, rod also expands. Some force acts on the wall. At the same time, wall some force acts on the rod. So rod also expand little bit. So at that time, so rod some more force acts. So strain because both are free end. For example, free end, it is easily to expand. It is easy to expand without any strain. But this strain also act. Stress and strain. What is the stress? What is the stress? Stress means some force and a force. Some force acts, this is called stress. What is the strain? Strain means the rod is expands in between the walls. This is called strain. For example, your work is finished within 2 days. Within 2 days, not a 1 month, not a 1 week. So, for example, your weekend syllabus compared to the last before week, so only one track is there. So physics one track and chemistry one track. It is easily to finish weekend syllabus. But last week and this week and further weeks also, not only one track, 2 tracks are there. 2 tracks, physics 2 tracks and chemistry 2 tracks. So week only 7 days, duration 7 days, 1 day also left, actually Monday complete is left, remaining 5 days. Okay, remaining 5 days. So 2 tracks and botany and zoology. So 6 tracks are completed within the 5 days. Is a more strain because you have more strain. Is a not a free more strain. For example, this syllabus you completed in 2 weeks, so it is a some strain also decreases. It is free. It is free to you cannot read. Okay, but within the week, within the days, within the both are rigid wall. Rod is fitted to rigid wall. Some strain also developed in a rod. Is not free to expansion. Not free expansion. Is some strain also developed. So this is called stress and strain. Stress means force. Strain means this is also change of length in between the walls only. In between the walls. Right. Okay. So third one. So temperature, right? Temperature of surroundings increases by delta T. Temperature increases by delta T. Temperature, if the temperature of surroundings better, if temperature of surroundings if the temperature of surroundings increases by delta T. So the natural increase in length increase in length due to thermal expansion due to thermal expansion is given by delta L is equal to L alpha delta. Alpha equal to L2 minus L1 by L1 into T2. So delta L equal to L alpha delta. Therefore, F for N is the normal reaction force. Let N be the if N be the let N be the normal reaction force. So normal reaction force on rod, cross-sectional area is A. Then stress. Actually, original topic in elasticity chapter, mechanical properties of solid chapter. Stress three types. Actually, longitudinal stress, volume stress, bulk stress. Shearing stress, longitudinal stress, volume stress, shearing stress. Strain also three types. Longitudinal strain, volume strain, bulk strain. Again, modulus.
Young's module.
Modulus, rigid modulus, bulk modulus. This is the original chapter in mechanical properties of solids. So let N be the normal.
These all are there, no sir, for Sunday's exam. These all are there, no sir, for Sunday's exam.
There. These are there. But topic applications must and should is there. But original topic in elasticity chapter, mechanical properties of solid chapter.
Okay, sir.
So then stress equal to force by area. Force means stress means like a pressure. Pressure and force are same. So stress equal to F or N by A or F by A or N by A. Normal reaction force or force by area or normal reaction or force anyone. So stress equal to F by A. That was strain. Strain equal to delta L by L. Change in length by original length. Just a little bit change of length, but change in length by original length. Change in dimensions to original dimensions is called strain. So delta L by L is strain. What is delta L by L? That is equal to alpha delta T. Alpha delta T. Right. So stress means F by A or N by A. Strain means delta L by L. So delta L by L means alpha delta T. So temperature increases from T plus delta T. This is a temperature, only T temperature. So temperature increases T plus delta T. This is a temperature, only T. This is a temperature T plus delta T. And temperature increases. The temperature is normal temperature, room temperature. Right. So actually, elasticity, stress is directly proportional to strain. Stress is directly proportional to strain. Stress equal to E into strain. E is a proportional constant is called modulus of elasticity. Modulus of elasticity E is equal to stress by strain. So modulus of, there are three types of modulus: Young's modulus, rigidity modulus, bulk modulus. But in this chapter is Young's modulus. Right. Next. Therefore, Young's modulus. Young's modulus denoted by Y. Y is equal to longitudinal stress until along the length. Longitudinal stress by longitudinal strain. Longitudinal stress by longitudinal strain. So Y is equal to F by A by F by A or N by A by delta L by L. F by A by delta L by L. F by A by delta L by Young's modulus. The ratio actually within the elastic limit, the ratio of longitudinal stress to longitudinal strain is called Young's modulus. So modulus of elasticity, there Hooke's law. In lower classes, Hooke's law is there. Hooke's law. Stress is directly proportional to strain. Okay. Previous 10th class or 9th class was Hooke's law.
No, sir.
No.
Right.
Sir.
Hooke's law, the same. Stress is directly proportional to strain. Stress equal to E into strain. E is the proportional constant, is called modulus of elasticity. There are three types of modulus: Young's modulus, rigidity modulus, bulk modulus. So original chapter in mechanical properties of solids. Right.
Sir, sound lo kuda edo modulus involve avutadi kada.
Sound is there. Wave chapter also ante velocity of sound V is equal to root of Y by rho. Velocity of sound in solids root of Y by rho. In liquid root of K by rho. Gases gamma P by rho. Newton Laplace correction. Wave chapter.
Sir, what is that, sir? Young's modulus Y is equal to B and GI.
Formula. This is the formula. Longitudinal stress by longitudinal strain. Longitudinal stress is also F by A. Strain delta L by L. Longitudinal means along the length.
Okay, sir.
Only along the length. Right. So therefore Y is equal to, therefore Y is equal to F by A into delta L, L by delta L. Therefore, thermal stress equal to F by A is equal. F by A is equal to Y into delta L by L. So that equal to Y into, what is delta L by L? Alpha delta T. This is called thermal stress. Thermal stress formula Y into Y alpha delta T. This is the here thermal stress. Thermal stress is Y alpha delta T. Sorry, thermal stress. Next one be thermal force. Thermal force. F is equal to cross multiplying. So Ya alpha delta T. This is called thermal force. Thermal force formula Ya alpha delta T. Thermal force Ya alpha delta T. Ya alpha delta T. Thermal stress formula F by A is equal to Y alpha delta T. Thermal force formula F is equal to Ya alpha delta T. Ya alpha delta T. C. So temperature and stress are same, then y alpha equal to constant. So y1 alpha 1 equal to y2 alpha. y1 alpha 1 equal to y2 alpha. D. Rod. If rod is placed on smooth surface, then stress is equal to 0. There is no stress developed because of slips on surface. Rod slip on surface. Because the rod slip. The rod slip on surface. The rod slip on surface. So refer one problem in exercise, maybe 2 or 3. One problem there.
Sir, once you move, sir.
Okay.
Sir, problem 12.26 also, sir. Example. Example problem 12.26 also, sir.
Not example 2.6.
12.26.
Right. 31. Exercise 2. 31. A steel rod of length 1 meter rests on a smooth horizontal base. If the heated from 0 degrees C to 100 degrees C, what is the longitudinal stress developed? So 0. Answer is first option is 0. Because not a stress between two rigid walls are fixed, not a fixture between two walls, just only on smooth surface. So
Sir, which question?
31. Exercise 2, 31. My middle is 31.
Sir, even our material also 31 only, sir.
31.
Okay,
Right.
sir.
A
Yes,
steel
sir.
rod of length 1 meter rests on smooth horizontal base. Okay. E. Right. This is the brass steel. Two different materials. So Y1, Y2. Modulus is different. Alpha 1, alpha 2 also different. So alpha 1, alpha is a brass. Alpha B, alpha S, YS. So displacement, for example, both are, so two different materials are combined to form a single rod, which is placed in between two rigid walls, two vertical walls. So it is heated. Surrounding temperature also increases. Temperature increases. Rod also, both are rod is melted. Some displacement, and the first one, this also heated, this one, and this one heated, this one, a little bit also expand. So displacement of the rod, common calculation, displacement. Displacement of the common, displacement of the junction rod. Displacement of the junction. Displacement of the junction rod. So refer example problem. Example problem. Akash material, example problem.
12.25.
Which one?
12.25.
12.25.
Yes, sir.
Okay. So final formula. Take write down final formula. Right. final formula x equal to right. So x equal to yb alpha b minus ys alpha s into L naught delta t by yb plus alpha s. L naught is the initial length of the rod, initial length. Delta t is the temperature, increase of temperature, delta t. So no need of proof. So yb alpha b x equal to, refer workbook one problem, workbook, refer workbook. Workbook may be level 1 or level 2. Level 2. So junction displacement of the junction rod calculated. So x equal to yb alpha b minus ys alpha s into L naught delta t by yb plus ys. So yb and alpha b. Yb is the Young's modulus of brass rod. Alpha b is the coefficient of linear expansion of brass rod. Ys is the Young's modulus of steel rod. Alpha s is the coefficient of linear expansion of steel rod.
Sir,
Displacement of the junction rod x equal to yb alpha b minus ys alpha s into L naught delta t by yb plus ys.
sir, sir, in question they will give yb and ys, no?
Why? Young's modulus. Y is the Young's modulus. Young's
Sir,
modulus.
Young's modulus values they will give no, sir, in question.
Is given, not given. Just wait.
సార్ ఇస్తారా సార్ అడుగుతున్నాం సార్.
జనరల్ ఎగ్జామ్ లో ఇస్తారా?
Refer Akash mein workbook lo na workbook.
సార్ ఎగ్జామ్ లో ఇస్తారు కదా సార్, అంటే పక్కన బ్రాకెట్ లో
Y is given na 100%. Refer workbook.
Level 2 problem 11.
Workbook. Tell me na workbook. Refer workbook.
In workbook level 2 problem 11, sir.
Level 2.
11.
11.
Problem number 11.
Problem number tell me.
11.
11. Now Young's modulus are given yb and ys.
Yes, sir.
Given.
The given ratio of y1 and y2 and L1 by L2.
Yes.
Sir,
Given.
that is displacement card, sir. Coefficients అడిగాడు.
Level displacement ఉంటుంది. Direct displacement given.
ఒక్క నిమిషం.
Not displacement, sir. Coefficients are.
No. Displacement, not that problem. Another problem. You check it, another problem.
Yeah, sir.
Just wait. Workbook problem number 707. 77 or 7 or 77 maybe. 7 or 77.
లెవెల్ 1 సార్,
Level 2.
లెవెల్ 2. ఓకే సార్.
Level 2 7
Read
is
the
there.
question, sir. Sir, once can you read the question?
Not there. This is the only way. Level 2 maybe 7. 7 you read.
Let's do 7, sir. Very on, sir.
Sir, the moment of inertia question, sir.
Sir, options you tell, sir. In that answer ka options.
Problem లేదా బై నా దగ్గర ఉంటే నేను చెప్పనా?
Okay.
Number.
So, question number 10 is about force.
Exercise 2.
Thermal force adding.
చూడు ఇట్లా చూడు, ఇట్లా వాల్యూమ్ సి ఉంటుంది. సెకండ్ ఎక్సైజ్ చెక్ రండి. డిస్ప్లేస్మెంట్ ఆఫ్ ద రాడ్ ఈస్ క్లియర్ మెన్షన్. లేదా
1 minute.
Sir, not there, sir. Sir, 10:30, sir.
Okay, right. Next one.
class is there.
Sir, Young's modulus
Level
questions
two,
ఉన్నాయి.
problem number 7 is correct. Option x equal to 10 into alpha 2 minus 2 alpha 1.
Sir, 11th one only then.
7th one, my middle is 7th one. Answer is x is equal to alpha 2 minus 2 alpha 1. Alpha 2, 10 into
10.
alpha 2 minus 2 alpha 1.
Option 3, no, sir.
X 10 into alpha 2 minus 2 alpha 1.
Sir, level 2.
11th question only.
Workbook exercise 2, level 2, problem number 7 is my workbook.
11th, sir.
Okay, na, bye.
Sir, level 1, sir.
Thank you, sir. Bye, sir.
Thank you, sir.